All right, for homework, you guys had questions on page 26 and 27. The first part says, use the distributive property to solve the following two equations. All right, so we know a strategy when we have an equation with fractions. We know how to get rid of those fractions by multiplying through by a certain number. The first thing I see, though, is we have fraction, fraction, mixed number, and then a fraction. So I want to change this mixed number into an improper fraction by doing 3 times 13, which is 39, plus 1, which would be 40 over 3. All right, now what I'm going to do is just bring down all the other terms. When you have an x, you can write it as part of the numerator, or you can put it to the side. I'm going to just write it as part of the numerator since we're trying to get rid of the denominators. All right, and then on this side, I'm going to bring down the 8 over 3x. All right, so when I look at all my denominators, they're all matching. They're all a 3. So that tells me that I don't need to skip count by anything. I can just multiply this entire equation by 3 over 1. All right, so in order to do that, I'm going to take the 3 and I'm going to multiply it times every single numerator. So 3 times 5x is 15x, plus 3 times 1x is 3x, equals 3 times 40 is 120, plus 3 times 8x is 24x. So there's all my numerators, just multiplied by 3. Now I'm going to go to the denominator. All of the denominators will be multiplied by 1, which will give me a 3 in all of those. All right, here's where the fractions disappear. We're going to divide 15 divided by 3 gives us 5x. 3's reduce to 1x. On this side, 120 divided by 3 is 40. And 24x divided by 3 is 8x. Now it just becomes solving the equation with variables on both sides. But when I look at the left-hand side, when you have variables on the same side, we can combine those like terms. So 5x and 1x is 6x. And then I'll just bring this side down. But I still see I have x's on both sides. So I'm going to have to get rid of this whole term, because if I got rid of the 6x, nothing would be left on this side. So the inverse of plus 8x is minus 8x, which is going to give me a negative 2x equals 40. Then to solve, we're going to do the opposite of multiplying by negative 2, which would be dividing by negative 2 on both sides. So x would be negative 20. All right, I still want to check and make sure that that's right. So if I do my check, I'm going to go and rewrite the original equation. I'm going to keep the 40 thirds just to keep it easier. All right, now I'm going to substitute in my negative 20. So it's 5 thirds times negative 20. Plus 1/3 times negative 20. Anywhere you see the x, you're substituting your answer in to see if it's true. 40 over 3 stays the same. And 8 times negative 20 over 3. All right, so now we're going to simplify. Here I've got 5 times negative 20, which is negative 100 over 3, plus 1 times negative 20 over 3. This is going to stay the same. 8 times negative 20 is negative 160 over 3. Okay, so when we're doing operations with fractions, like adding two fractions, you just have to make sure you have common denominators, which we do. So when we have common denominators, the denominator stays the same, and we do the operation with the numerators. Negative 100 plus negative 20 is negative 120 over 3. Same thing here. I've got common denominators, so 40 plus negative 160 is also negative 120 over 3. So my answer checks. All right, let's go down to the second one. This one we don't have any fractions. We're just going to have to do some distributing. I'm going to put my line down here to show the two sides of my equation. The tricky part to this one is that we're really distributing this minus or negative sign. I like to put a 1 in there to show that I'm going to distribute a -1. So the 28 is just going to come down, and I'm going to do -1 times 3c, which is -3c. And -1 times +4 is -4. All right, now I'm going to go to the other side. 2 times c is 2c. 2 times a +6 is a +12. And then this is not inside the parentheses, so that's just going to come down. All right, now I'm going to look on the left side to see if I have any like terms I can combine. And I have these two constants. So remember, you have to take the sign in front of each of the terms. So my -3c is going to come down, but I can do 28 minus 4, and I get a +24. On the right-hand side, I have two like terms. Remember, you can always put a 1 in front of a letter if there's no coefficient. 2c plus 1c is 3c, and the +12 comes down. Okay, so now I have constants on both sides and variables on both sides. So I'm going to get rid of the -3c by doing the inverse, which is to add 3c. So then those are eliminated. 24 comes down. I have 6c plus 12. Now I want to get rid of the +12 because I have constants on both sides. I want to keep the c, so I'll do the inverse of that. 6 times c, and I'm left with 12. Okay, last step is to divide by 6. So 2 is my c. Quick check, you're going to rewrite the original. 28 minus 3 times c plus 4 should be equal to 2 times the quantity, c plus 6 plus c. Now I'm going to substitute my answer of 2 in. 3 times 2 plus 4. And then over here, 2 plus 6 plus 2. All right, let's simplify the left side. Inside the parentheses, I have 6 plus 4. Which is 10. So 28 minus 10 is 18. So let's check on the other side. If I simplify 2 times 2 plus 6 is 8 plus 2. I get 16 plus 2, which is also 18, so it checks. All right, well, let's go to the second page, 27. Page 27 is very similar to the ones that we just did. The only thing different is you're going to solve the two equations, and then you're going to identify how many solutions. When we said how many solutions, is there one solution where you get x equals a number, or is there no solutions? Or sometimes there's infinitely many solutions. Okay, so I'll do the first one with you, and then I'll let you try the second one. So same thing, I need to look, is there anything on the left-hand side I need to do? There's no distributing, but there are some combining like terms. So 6x and 19x is 25x minus 4. And then if I look to the other side, I do see distributing. I would get 25x plus 20. All right, now I'd like to move the variables. You can move either one since they're the same. If I subtract 25x, they're gone on both sides. So what I'm left with is -4 equals 20. Well, that is not a true statement. So in this case, there are no solutions because that is not a true statement. There's nothing that I could put in for x that would make that equation true. Okay, so you're going to do the same thing on the bottom. You're going to solve, and then you're going to determine, did you get x equals a number? Is it a false statement where there's no solutions? Or are there infinitely many, meaning that the two sides equal each other?